Welcome to Conquering the JavaScript Interview. I'm Luke, your interview conqueror, teacher, mentor guy. So come with me, young Padawan, because we are here to talk about our first data structure in this playlist. This is one of those things where I don't think you're ever actually going to be writing it in an actual project. I mean, get in the comments if y'all have, if you've done something like this before in an actual project to help yourself out. When it came to data storage, but data structures are more of like they are used. They're fundamental and fun like theory to think about. Um, to basically pass the interview. Like I've seen my students get asked a couple of these kinds of questions like stack versus queue and defining the difference of them. So not necessarily coding and implementing them because again you might have libraries or pre-built in things that do that for you, but being able to discuss them. And I think you being able to code them helps you be able to discuss them, right? So we kind of think of data structures as like nice and performative ways to store data, right? That's what they're meant to do. And how they store that data and how they manage it, whether it's like if you're thinking from anyone has retail or inventory experience, you might be thinking FIFO and LIFO. There are two different ways of managing your inventory: first in, first out FIFO, last in, first out LIFO. And LIFO is actually what a stack ends up doing. I like to think of it almost like doing a stack of dishes at a restaurant. If you were like a dishwasher, you know, if you have a giant pile of plates that you have to start washing, where do you typically start? Well, you start at the top and pull them off from the top and work your way down to the bottom. And that's what the stack ends up doing code wise. So while you could make like your own function or prototype in JavaScript, and as a matter of fact, we already know that arrays have push and pop methods on them, which kind of makes the implementation fairly simple by just using a simple array as a variable. We're going to choose to add a couple of methods to a JavaScript class object in order for it to perform, well, the basics a stack needs to do. For example, pushing an item into the stack, popping one off the stack, peeking at the top of the stack, checking if it's empty, which probably shouldn't have an argument. Sorry, copy paste got the better of me there. And then maybe one called print stack that's purpose is to print everything out there. So yeah, we're basically implementing a LIFO inventory management system with stack. If anyone out there has that retail experience, you know what I'm talking about. So this one's not too terrible code-wise to implement. And like I said, it will help you answer these kinds of theoretical discussion questions in interviews because you may not specifically code it, but again, being able to know how it's implemented and seeing the code in your mind's eye can help you discuss it during an interview with your interviewer. So let us begin. In our stack, when we make a new one, we got to make sure that when we instantiate a new class instance, all these crazy words when it comes to classes now, when we instantiate a new class of stack, we want to construct itself with a new array. So we're going to make it this property, something like this dot items is going to be an empty array when we create a new stack like so. So now we've generated an empty array that this variable can reference and use and do things with. So that's where this thing begins. An empty array, no problem in our constructor. That's really all that it's going to be done to it. So from there, let's go ahead and go with the next one, which is adding an item into the stack, whatever that item may be. We're probably just going to use numbers or letters in this demo as always. So we're going to have a method on this class called push. It's going to take an item, whatever that element item may be, and it's going to push it into the stack. To do that, we're going to reference the array property, this.items. Arrays in JavaScript conveniently already have a method called push that allows us to add that item into our stack data structure. Okay, so far, like I said, not too difficult. It's more important about how the stack works in terms of its data management. Remember, LIFO, last in, first out. The top of that stack of dishes is the first one that's going to go out when it's time to remove something from the stack or do something with that data. Next, we need to have our pop method, and pop is also conveniently a JavaScript array method already available to us. Popping an item should return to us whatever the top element is, while simultaneously removing it from the array itself. So what we're going to do is write pop, and we're going to return this.items.pop. And the pop method on JavaScript arrays should also return the last element from the array. Yeah, so it removes the last element and returns it to us. So this will return the last element, aka the one on the top of our data structure, our stack, and it's going to pop it off the stack and give it to us to do something with. So that's what the pop method is going to do. Now, it would be wise to consider a small edge case scenario here. If we try popping something off of an empty array, let's see what that ends up doing for us. If I write an empty array and write .pop and save this file for the console log, we get undefined. So, you know, that maybe that's fine if you want to write an if statement or something like that in your code when popping a method off, or we can add that into our class method itself to say if this.items.length is 0, then we need to return something like no items, or I can't remember the correct term for this, something like there's nothing left to pop or something like that. That way it returns something, or even just like a false, because it can't actually pop anything, right? We need to just not be able to return undefined. I'd rather it return something like that I've programmed, like this Boolean value of false, or a string value of like underflow, or not enough items, or something like that. Just thinking of edge cases to start bumping us up from that beginner tier of coders and developers. Cool. So just wanted to explore what that right there with a little edge case we can keep in mind. Next up on our list is the peek method to this stack data structure. The peek is going to be just taking a look at the topmost element of the stack. So as we're washing our stack of dishes, peek would say I can just look over and eyeball. Oh, that's a breakfast dish right there, so I'm going to have to really scrub down the eggs. By the way, I worked at a dishwasher for about a year at a coffee shop before moving up in that place, which is why I keep referencing dishwashing. But I remember my breakfast and brunch plates were the worst to wash because those eggs were horribly annoying to scrub off if they dried. Anyway, the peek method's purpose is that, to peek over to see what the next plate's going to be, to see if we have to do something custom or if it's going to be bad or something like that. So the point of peek method is to take a look at that top level element. And to do that and have it scale, we need to reference the array's final index position, which is a little bit of fun code here of this.items.length minus 1. So remember, the length of an array is counted from starting point of 1. The index of arrays are counted starting point of 0. So if we take the length and subtract 1, that will always be the last element in the array. And we'll return it from this function. That way we can take a peek at what it is, but this doesn't actually remove it like pop did. This takes lets us take a look at it. We should know if the stack is empty. Maybe we want to test that some point down in our code, or in our in the flow of our application somewhere. We need to make sure that the data storage structure that we're using, the stack, is empty or not. So we can make a isEmpty method here that will return true or false if this.items.length equals 0. So if the length of this stack is 0, it will return true. Otherwise, it will return false. This is a Boolean return value from this isEmpty class method that lets us know if it's empty or not. And then finally, what was the last one we had here? Oh yeah, print stack. I mean, typically you don't really see this one all the time, but I figured we add it in here for some fun, because why not? So we can choose to do it in a couple different ways, because y'all might be thinking, well, dude, wouldn't printing the stack just be boom? Yeah, that could be as simple as a solution needs to be, just printing out what the array and the stack is. We could also individually print out each item, so we could do something like a for loop, where we can use a for of loop, const element, or ella, or items, or whatever you want to call it, item of this.items, and we can console log each item. Or if we wanted to like see each element in the stack individually, we could always do something like this. Let items be an empty string, and then we can concatenate items plus equals a space plus item. Or I could just do a template literal and be like item, instead of having to concatenate empty space and what's it called? Another plus sign and another string. Okay, there we go. Template literal for the win. And then after that, we can console log our items out. So there's a couple different implementations of the print stack that we can visualize here, but just keep in mind that this one's kind of up to interpretation, which is why I'm not giving y'all which way you should do it for a print stack. Like I said, console logging this.items in my head is easy enough to print the stack out if it's an array value. in JavaScript, but that should round out the methods. So this is like, again, classic data structure. I think the next video I'm going to make will be Q, and you'll see how similar it is. And then maybe a video kind of breaking down the data structures, maybe visually, if that helps some individuals out there. But again, keep this in mind. Like I said several times at the beginning of the video, it's less about how you implement all this code. It's more about understanding that the stack is that LIFO, last in, first out. That stack of dishes that you got to wash, you pull the top plate off and wash that, then pull the next top plate off, wash that, etc. So keep that analogy in your mind, because analogies and being able to describe like the implementation of a stack data structure and also throw out an analogy shows your interviewer that not only have you just memorized a code solution for it, but you also understand it on a fundamental enough level to give them an example or analogy that complements what you're trying to describe technically, right? So that will, again, wow your interviewer and, well, again, make you look like a cut above the rest, which is the purpose of this entire playlist. So from here, I think it is time to now do some testing, right? So let's go ahead and confirm that if I console log my current stack and I call my isEmpty method, it should return true because it's indeed empty. From there, we should be able to, let's start adding some stuff. So we'll say push. We'll do a 1, 2, 3, like so. There we go, 1, 2, 3. We push it into the stack there. Now let's go ahead and write stack.print stack so we can see our string concatenated numbers printed out to us. Why did I get undefined? Oh, okay, so I got undefined because this method does not return anything. So maybe we should write, instead of console log inside of here, we should return our items out to us. Because this method did not return something, this outer console log here on line 51 caused the undefined, right? And it happened after our string concatenated 1, 2, 3 right there. So I should probably do it this way, honestly. There we go. Okay, so let's try that again with our corrected code. There we go. So yeah, the true is again from the isEmpty on line 45 because this code is synchronous, running from top to bottom. Pushes in 1, 2, and 3. We asked it to print it. It concatenates 1, 2, 3 as our data structure, with 1 being on the top of our stack, that top dish. From there, what methods we got? Let's go ahead and pop 1 off. So we'll say stack.poperino. That should pop off a number for us at the top of the stack, being that 3. I think I mistakenly said 1 is the top of the stack. I meant 3. Yeah, so 3 is at the top of the stack because it's the last thing I added, and it's the first one out. So not only did it remove it from our stack, but it also it printed out for us what it removed here. So the next bit of code, if I wrote stack.print stack once again to visualize what our stack looks like, it should hopefully just be a 1 and a 2 and a, there we go. So looking good so far. I think our methods are working the way they should. We've pushed things in, we have popped things off, we have taken a peek, and we have run, actually we haven't peeked yet, have we? No, we haven't peeked. And we've done print stack, we've done isEmpty. So if we run at the end here, hey stack, I want to take a peek at what the current item in the stack is. It should hopefully be a 2. And yeah, there we go. There's our 2. They got printed. That's the peek. We're taking a peek at the top of the stack of dishes. And we have our methods implemented and hopefully a understanding of a cool and simple beginner-friendly data structure to start rounding out like the practice with all the algorithms we've done in this playlist so far and starting to pick up on some of the data structures. I'm not looking forward to doing bubble sorts and all that kind of fun stuff later, but that'll be for probably the more advanced part of this playlist near the end, because I want to keep all the beginner and intermediate stuff towards the beginning. So yeah, this is me signing off. Make sure to like, comment, and subscribe. Check the description down below to get involved in our Covalence Discord community, and I will see y'all later.